Hello students. I hope you have gone through the last lecture, which was a revision of the concepts of differentiation. In this lecture, we are going to go further in the lesson and start with composite functions. Be patient, concentrate, go through the entire video so that you are able to grasp what I am trying to tell you. Consider this equation, y is equal to 3x plus 1. This is an example of a simple function. What about this one? Y is equal to 3x plus 1 the whole square. This is what is called as a composite function. As you can see, it is a bit more complex as compared to the previous one. It is a function inside a function. One more example, y is equal to log x is a simple function, whereas y is equal to log of log x becomes a composite function. So we can say a composite function is a function inside a function. It is represented as y is equal to f of gx. Now the question is how to find the derivative of a composite function. Now suppose y is equal to f gx is a composite function. Then dy by dx becomes f dash of gx into d dx of gx. So what is done over here? The derivative of f, the function f is found first, and then the derivative of the inner function, that is gx, is found next. In general, we can write dy by dx is equal to derivative of the outside function into the derivative of the inside function. So this outer inner rule is what we are going to follow for all the following sums which are there. We also call this as the chain rule. So remember, derivative of a composite function is obtained by first finding the derivative of the outer function f and then finding the derivative of the inside function, that is g. Now the exercise. The question is going to be find dy by dx. The first sum, y is equal to root of x plus 1 upon x. So in the solution, now root of anything is actually raised to 1 upon 2. Root 2 is 2 raised to half. Root 3 becomes 3 raised to half. Root 6 becomes 6 raised to half, and so on and so forth. Therefore, root x plus 1 upon x becomes x plus 1 upon x raised to half. Now, what is the derivative of y? That is, what is dy by dx? As you remember, the outer inner rule, that is derivative of the outside function into the derivative of the inside function. What is the outside function? Outside function is x plus 1 upon x raised to half. Now consider that x plus 1 upon x as one big x. Suppose instead of x plus 1 upon x, only x was given. So it would be x raised to half, isn't it? The outer bracket raised to half. So what rule would you use for finding the derivative? You would use the rule of x raised to n, isn't it? X raised to n is equal to n into x raised to n minus 1. So x raised to half becomes half into x raised to half minus 1. Now instead of x, put x plus 1 upon x, like this. So the outer function x plus 1 upon x raised to half becomes half into x plus 1 upon x raised to half minus 1 using the formula x raised to n into the derivative of the inside function. Which is the inside function? Here whatever is there inside the bracket is the inside function. So derivative of x plus 1 upon x. So in the next step, we get half x plus 1 upon x raised to minus 1 upon 2 by solving that raised to whatever. Okay. And the derivative of x plus 1 upon x. ddx of x is 1 and ddx of 1 upon x you already know. It is minus 1 upon x square. So thus the answer comes out to be so. The next sum, y is equal to the cube root of a square plus x square. Now, cube root of anything is raised to 1 upon 3. Cube root means raised to 1 upon 3, raised to the power 1 upon 3. So the cube root of 5 raised to 1 upon 3. The cube root of 4 is 4 raised to 1 upon 3. The cube root of anything, say 100, is 100 raised to 1 upon 3. Similarly, the cube root of a square plus x square is a square plus x square raised to 1 upon 3. So we just write y is equal to a square plus x square the whole raised to 1 upon 3. Now what about the derivative of that? Same thing, we use a chain rule, that is the outer inner rule. We first find the derivative of the outer function. What is the outside function? It is a square plus x square raised to 1 upon 3. That means the bracket raised to 1 upon 3. So what is the derivative of a bracket raised to 1 upon 3? It is 1 upon 3 the bracket raised to 1 upon 3 minus 1. Whatever is there in the bracket is written as it is. Into the derivative of the bracket. That is derivative of, in this case, a square plus x square. Just concentrate for a few minutes and you will understand the concept here. Thus in the next step, it becomes 1 upon 3 a square plus x square raised to minus 2 by 3, solving that 1 upon 3 minus 1 into derivative of a square. Now a square is a constant. ddx of any constant is 0 and the ddx of x square becomes 2x. Thus by simplifying it, it becomes our answer here. In the next sum, y is equal to 5x cube minus 4x square minus 8x the whole raised to 9 is given. Here the derivative becomes again using the chain rule. First the derivative of the bracket raised to 9. Anything raised to 9 becomes 9 the same bracket raised to 8, isn't it? So here it becomes 9 into the bracket raised to 9 minus 1 into the derivative of the bracket. The bracket here it is 5x cube minus 4x square minus 8x. Thus in the next step, we simplify the whole thing. Now what is the derivative of the second bracket there? See the last part of the sum, previous step. The derivative of 5x cube is 15x square. The derivative of 4x square is 8x. And the derivative of 8x is 8. Thus we get the answer. The next sum can be done same like the third sum as an assignment. Now we go to the next sum. Again this sum, if I just simplify one step for you, you can do the entire sum as an assignment. That is, I have simplified the step over here. Just study the step, what simplification has been done, and then do it as an assignment. Question 2, a different type of question, that is find dy by dx if y is equal to log x. Here we are going to deal with log sums, which can be done easily, don't worry. So now what is the derivative of log x first of all? The derivative of log x is 1 upon x. Therefore, in the solution, y is equal to log x. Now the outer log is considered as the outer function. Obviously, the log inside the bracket is the inner function. We are going to use the same chain rule, finding the derivative of the outer function first and then multiplying it by the derivative of the inner function. The same rule. So thus dy by dx becomes derivative of the outer log. Derivative of any log is 1 upon the function, isn't it? So as a result, derivative of the outer log 1 upon log x. Derivative of log x 1 upon log x into, by chain rule, ddx of log x as well. Thus we get 1 upon log x into ddx of log x is 1 upon x. Thus we write that 1 upon x over there. And then we just simplify and write the answer. In the next sum, y is equal to log 10x raised to 4 plus 5x cube minus 3x square plus 2 is given. Again, log is considered as the outer function and whatever is inside the bracket is considered as the inner function. So as a result, by chain rule again, dy by dx log of the bracket becomes 1 upon the bracket into ddx of the bracket. Thus in the next step, the first part is the same. In the next part, the derivative of 10x raised to 4 is 40x. 10 is kept as it is. X raised to 4 becomes 4x cube. So thus it is 40x cube plus 5x cube becomes 15x square. 3x square becomes 6x and the ddx of 2 is 0 because 2 is a constant. And thus in the next step, the simplification is done and the answer we get over here. This sum can be done as an assignment, same like the previous sum. Again, this particular sum, that is y is equal to log x the whole square. Now, there are 3 logs which are given there, isn't it? And there is a whole square which is given there. So the square bracket the whole square is the outermost function here. The first log is the function inside that function. One more log is there which is an inner function as well. And then there is an innermost log over here. So we start by finding the derivative of the outermost function. So dy by dx is, what is the ddx of x square? It is 2x, isn't it? So the derivative of the bracket square becomes 2 into the bracket. So dy by dx initially it is 2 into whatever is put in the bracket. In this case it is log x into derivative of log x. Thus from this particular step, the next step you see that 2 log x remains as it is. What is the derivative of log x? First we find the derivative of the outermost log. It becomes 1 upon log x. And then we multiply it with the derivative of log x. And then in the next step, the first part remains the same, that is 2 log x into 1 upon log x into the derivative of log x is actually 1 upon log x. Again, the part is not over. Okay, we still have log x to be derived, found the derivative of. So we find the derivative of log x. And thus we get it so. See the last part, only the last part. ddx of log x has become 1 upon x. Now we just have to simplify the sum and we get the answer. In this group of questions now, the first one, y is equal to e raised to 5x raised to 4 minus 2x plus 4. So, remember, the derivative of e raised to x is e raised to x itself. In these type of sums, e is considered as the outer function and whatever it is raised to is considered as the inner function. So, by using the chain rule, first we find the derivative of e raised to the bracket and then we find the derivative of the bracket. So, dy by dx becomes e raised to 5x raised to 4 minus 2x plus 4 into derivative of whatever is raised to, that is 5x raised to 4 minus 2x plus 4. Then, next step, the first part remains as it is. The derivative of 5x raised to 4 is 20x minus ddx of 2x is 2 and 4 becomes 0 because it is a constant. And thus the answer. In the next sum, y is equal to a raised to 1 plus log x. Now remember, the derivative of a raised to x is a raised to x log a. So thus, y is equal to a raised to 1 plus log x is given. So here, a raised to the bracket is the outer function and the inner function is the bracket which it has been raised to. So using the chain rule, dy by dx becomes a raised to 1 plus log x log a into ddx of 1 plus log x. Thus we get the last part 1 plus log x. Now ddx of 1 is 0 and the derivative of log x is 1 upon x. Thus we simplify and get our answer. Now these two sums can be done as assignment. So in the next lecture, we will begin with the next concept of the lesson. Keep practicing, students. Bye.